Hey there, I'm Cole Bowden. In this video, we're going to be talking about aggregating indexes, a unique optimization and feature in Firebolt. Aggregating indexes allow you to pre-compute the result of aggregation functions on a table. This works similarly to how materialized views work in other systems. However, aggregating indexes are maintained automatically in Firebolt as you insert, update, or delete values from a table, making sure that when you go to query that table, the results of those aggregations are waiting for you and your queries can run as efficiently as possible. You can also define multiple aggregation indexes on a given table, so that if you have different query patterns accessing different aggregations, you can create these different indices, and the query planner will intelligently select the aggregation index that will most efficiently speed up your query and make sure that you can get your results back as fast as possible. The simplest form of an aggregating index in Firebolt is one where you apply it to the entire column within a table. So you can compute the sum or the minimum or the maximum or the average of values in that table for that column. This helps you when you're looking at all of the data in that table, but in the real world, you're very frequently only going to want to look at a subset of your data, and that's why there's this notion of grouping keys that you define as part of your aggregating indexes. So if I have a sample table where, for example, I have a date column and a revenue column, when I define my aggregating index, it's likely that the thing I'm interested in aggregating is revenue. But I'm going to want to look at revenue within certain windows or groups of dates. Say, revenue in the last hour, or in the last day, or in the last week, month, or year. And in order to make it work, I can't just have an aggregating index on all of the revenue values. I need to have it for certain date windows. And so what we can do is we can define a grouping key on the date column, and that will make sure that our aggregating index is aware of the aggregations within certain groups of dates. And that will ensure that your aggregating index is indexed on date so it can efficiently retrieve the aggregations for revenue. And so for revenue, I think we might want max. It's the best transaction, the biggest transaction in a certain amount of time. We could probably have sum. We're interested in looking at how much revenue has come in certain time frames. Maybe we're interested in average. We want to see what the average transaction was in this table. And we can have all of these aggregations and then the grouping key on date to efficiently retrieve any one of these aggregations on the revenue column when we're filtering by, grouping by, or ordering by the date column. All right, now let's try this out in Firebolt. I'm going to add one note, which is that your grouping keys for your aggregating index work better on columns with low cardinality. This means a finite or small number of unique values. In the example I'm about to show you, it'll be on a country code column. Because there's only so many countries on Earth, that's beneficial for the purposes of an aggregating index. I'm also using the Firescale dataset with the user visits table, which is about 1 terabyte of data. So first, I'm going to show you an analytical query where I'm trying to calculate average revenue for a few different countries. When I run this query, you're going to see that we're going to begin scanning data and looking at this entire table, or at least parts of this table, to try to understand what's going on in each of those countries as defined. We can go look at an aggregating index that I already created on this table, where I'm grouping by that country code column, and then I'm also pre-computing the average ad revenue for each country. So the base query that I ran here took about 14 seconds. Now, if I move to the table that I've defined this aggregating index on, and I run the query here, you'll see that we returned results literally instantly. We only had to scan 4 rows of data, barely any of it, and we were able to get results back as efficiently as possible. This is the power of a well-defined aggregating index. And based on your query patterns and how much data you're looking at, you can tailor your aggregating indexes to speed up the specific queries that you're running a lot. Aggregating indexes are a very powerful tool in Firebolt, but there's a couple other technical considerations to be aware of. They have the advantage over materialized views in that they never present you stale or old data. However, to maintain an aggregating index, they have to be updated when you're running DML operations like insertions, updates, or deletes. Because they're being maintained as part of this, that can incur a little bit of overhead on these operations and limit their performance a little bit. The other thing is that the more you run those DML operations on a table in Firebolt, the more fragmented your aggregating index is going to be, which can limit its performance somewhat. In order to adjust for this, you can run vacuum operations on your aggregating index to reconsolidate the data and speed it back up. For more information about aggregating indexes, check out the Firebolt documentation. Thanks for watching.